Hey guys, welcome back. Today we're going to be looking at the idea of completing the square. And the occasion when this issue comes up is obviously when we're dealing with quadratics. We're still talking about equations or expressions that have this x squared term as the highest power x term. So we don't have an x cubed, but we have x squared and potentially another term with x and a number. Okay, but as long as the equation has x squared, we're calling it a quadratic. Okay, so for these quadratics, we get a problem when questions want you to solve them or factorize them. Because as you can see from this equation, for example, x squared minus 10x plus 18, there is no common factor straight away. Which means I can't simply take something out and put the rest in brackets. We can see that both of these terms have x, but this one doesn't. Both of these terms are divisible by 2, but this one isn't. So there's no number or pronumeral that I can take out straight away for the sake of simplifying the way this equation looks, which will help us solve an equation later. For example, if I made this equation equal to 0, if I wanted to find what x values make this whole left side equal 0, it's very hard to do just looking at that. We obviously need to simplify the expression by factorizing it so we can make brackets, and then we can make each bracket equal 0, and then that will give us the answer. We need to make this expression into two brackets that don't have an x squared in each of them. We only want x and x so that we can see clearly what x values need to be in each bracket to make the whole bracket equal 0, and therefore the whole side will equal 0. Okay, so that's the problem we're dealing with. Now, we're also looking at a trinomial here. A trinomial is a quadratic that has an x squared term, an x term, and a constant. Okay, it has all three of those components, right? So when you get a trinomial, how do you factorize? Well, you always go and try out the PSF method, which I've explored in another video. But sometimes the PSF method won't work. It won't allow you to simply put this expression into two brackets. Okay, when will that happen? Well, we know that when we do PSF, the method in this case would just be to say the P is going to be 18 because we're dealing with a monic. There is a 1 before the x squared. So we just take this 18 here and we say, okay, the P is 18. The S is minus 10. And I need to find two numbers that multiply to 18 and add or subtract to minus 10. And what you'll find is if that I go through all the combinations of numbers, two numbers that multiply to 18, none of them will add or subtract to minus 10. So that's a problem. That means I can't think of two whole numbers here that will allow me to do the PSF method. But in reality, there is an answer to this equation. There are answers, but the PSF method isn't going to work in this case. And that is because the answers are not going to be whole number answers. We might be looking, if this was a parabola, basically it's saying that where the x-intercepts are, right? Again, if this was a parabola, and originally we had y equals x squared minus 10x plus 18, well, when we want to find the x-intercepts, which is what you would be doing here, is say the parabola looks something like this. These points are not like minus 2 and 2, rather they might be square root 2 plus 1. Or something like that. There's a surd involved there, a square root. PSF will not give you answers in that case, okay? So that's why we have this other method called completing the square. Okay, so a question may also ask you to specifically use completing the square to factorize and perhaps solve an equation, okay? But for now, I'm going to get rid of the equals 0. I don't need you to solve anything, but I want to rewrite this expression with two brackets so that it is fully factorized. Now, before we do that, there's two things you need to be comfortable with. The idea of a perfect square, because when this says completing the square, really what that means is creating a perfect square artificially. We're actually going to rewrite this in a different way so that it's still exactly the same, but we're going to manipulate it. We're going to change it around so that we can put a perfect square in there, which is going to make our lives a lot easier. So let's see what a perfect square means. Well, a perfect square, say we had x minus 5 squared. That's a perfect square. Two terms in a bracket with a square outside. And we know that if we did the long way to expand it, we would be getting x minus 5 times x minus 5 because it is the bracket squared, the bracket times itself. And then if we expand it the long way, times in each of these terms by each of these terms, we would get x squared, x times x, minus 5x, and then this one minus 5x again, and then plus 25. Now you'll notice that if I bring those two together, that's going to be x squared minus 10x plus 25. So what's really happened is what we've done is instead of doing this long way every time, when you get a perfect square and you want to expand it, this is expanding, right? Expanding is getting rid of the brackets, which is what we already have here. That's an expanded form. I want to get it back into the brackets. So they're the opposite processes. Okay? That's expanding. I should write here. That's expand. And if I pulled that back into that, that would be factorizing. Or factoring. Okay? So that's expanding, getting rid of the brackets, factorizing it back into the brackets. And you can see you'll see a pattern here if you do all these perfect squares. That really all you've got to do is look at the first term in the bracket and square it. X squared. Then times these two terms together. X times minus 5 is minus 5x, and then double it. You always double it because you can see here that it'll always be two lots of those in the middle. So it's minus 10x. It's minus 5x times 2, which is minus 10x. And then the last term will always be this last one squared, plus 25. Okay, so that is a perfect square, right? That's the first thing you need to know, right? But importantly here, you need to notice that this, if I was to reverse this process, if I was to try and get this back into the bracket, what you'll notice is that this term here, this minus 5, is always going to be half of this one. Because remember, we doubled them to do the shortcut. We times these together and times it by 2. So to get it back in, surely we have to halve it to get it back into the original. So what you'll notice is because this represents double of those two times together, half of this number, half of minus 10, equals minus 5, which is going to be the term here. Okay, so that gives you some insight into how you could go from this looking thing to in the bracket. Okay, great. And we also know, the other important thing to know is that if I halved this minus 10, because that gives me the number there, half of minus 10 is minus 5, minus 5 squared is the last term. So if we halve this minus 10 to get minus 5, then square minus 5, minus 5 squared, give us 25. So you can always match up. You can always find what this last number should be by halving this middle one and squaring it to get 25, okay? So if you got an equation that looks like this, let's have a look at x squared minus 6x. What number do I want on the end here for me to be able to put this whole thing into a bracket? Well, as I said, what's half of minus 6? Minus 3. Because remember, if it was a perfect square originally, we would have doubled the two terms in the bracket together. So I'm going to halve it to take it back to minus 3. That means minus 3 would be in the bracket like that. And what's half? And we know that minus 3 squared, the number that I've just put in there, is 9. So x squared minus 6x plus 9 is this perfect square. So you just saw there, I completed the square there. I halved the middle term next to the x. I don't actually include x when I halve, I just get the number next to it. And I square that to find what number should be on the outside to allow me to put that whole thing exactly into a perfect square. Okay, hopefully that makes sense. The second thing I want you to be familiar with, so that was number 1, that's the first requirement. Okay, I'm going to rub that out, because that was an example. Number 2, now I also want you to be familiar with the difference of two squares, right? So that was the perfect square. And this is going to be difference of two squares. Now this formula is another shortcut. If I gave you, excuse me, x plus 5, x minus 5, if you see the same two terms in brackets with different signs, well, all that expands to is x squared minus 25. The first number squared in the brackets and the second minus the second number in the brackets squared. So x squared minus 5 squared. That's the shortcut because the middle terms would have cancelled each other out. As I'll show you down here if you'd like. I'll do the long way again. Times in these, times in these. I get x squared minus 5x plus 5x. That's where you see the cancellation. They will always cancel. Plus 25. And I'm left with what I had up there. Okay, great. So we know that if we see a term squared, because remember now I'm going to look at it from the opposite way. If I didn't have that, pretend we didn't have that, I just gave you that. To factorize it, you know that you just have to put this first term, which has been squared in the bracket, plus the square root of this second term, because it would have been squared. So the square root of 25 is 5, so I put x plus 5, x minus 5. So you need to find basically the square root of this first term and the square root of the second term when there's a minus sign, not when there's a plus, only when there's a minus between two terms. Can you then put them into brackets like this? Okay, great. So let's go back over here and let's see how we can complete the square. Now you'll probably notice here, look at this. X squared minus 10x, x squared minus 10x. That had plus 25. And we figured out because that was exactly the square of half of that middle one. Remember, half of that middle one was minus 5, squared was 25. It worked out perfectly, so we can put that whole thing into x minus 5 squared. Over here, we don't have plus 25. Okay? So try and imagine this. We want to hold the plus 18 on the outside. And what I'm going to do is, I'm simply going to do this to our equation. I'm going to go, okay, we have x squared minus 10x. How could I form some kind of bracket in here? Well, if I had plus 25, and how did I get it? I halved this middle one, so I'm going to divide that number next to x by 2. Always make sure, by the way, that these are in this order, the x squared, the x, and the number in that order. And I would just want to look at the x squared and the x to start off with. Because I know half of that middle number, minus 10, is minus 5. Half of it is minus 5. If I square that, I get 25, just like we showed you before, right? That has given you the number that is required to put those three terms into a perfect square, okay? But I had plus 18. I didn't want plus 18. I want plus 25. So what I'm going to do is I'm going to hold the plus 18 on the outside here. What I'm going to do is I'm going to come down here and I'm going to go, okay, well, we have x squared minus 10x, and I'm going to add in 25. And you're probably thinking, how can you just add in plus 25? You had plus 18. Well, what I'm going to do to compensate, to balance the equation, I still want it to be exactly the same value as it was before, is I'm going to still write my plus 18 over here. The only difference between this line and this line is I've added 25. Therefore, I have to minus 25. The number that you add in, which will be the square of half of that number, must be subtracted off so that these two actually cancel each other out, don't they? Plus 25 minus 25 is 0. So really, if there's 0, I've still got that. I've just written it in a different way. Okay. Now you're probably thinking, why would you do that? Because I wanted to manipulate this because I know this bit here, as you saw over here, is a perfect square. We expanded it, and it's because that x minus 5 squared is the same as x squared minus 10x plus 25, surely it makes sense that I can write this as x minus 5 squared. Now, if I hadn't shown you that before, all you need to remember is that half of that middle term will be the one in this bracket. X minus 10 over 2 will be the number down here. Okay, I want to make sure that's very clear. I showed you over here the expanded form, but if you didn't have any of that, all you do is you grab that. Half of that is that's going to go here. Because you know that minus 5 squared is 25. Okay, great. So I get x minus 5 squared, and then I've got plus 18 minus 25, which is minus 7. Okay, and here's where things get a little bit more interesting. Now, it's still not fully factorized because as we showed over here with difference of two squares, where I had x squared minus 25, right? Or x squared minus 5 squared. Over here, I've got x minus 5 squared minus 7. Now there's a minus and two terms next to each other. It's not going to look obvious at first, but if I said to you, imagine that x minus 5 was actually a. So I want to make a, I want this bit to equal a. Okay, x minus 5 is a. Well, then the equation would look like this. A squared minus 7. A squared minus 7. That could be like x squared minus 25. Because what's the square root of 7? Root 7. So it's root 7 squared and a squared. So I do have a difference of two squares here. Okay? It's just that a is actually the same as two terms. So in your head, when you see a perfect square, you're thinking everything on the inside is just one value. Imagine it is like a. And we know that a squared minus 7 will factorize to a plus 7, or plus root 7, I should say, a minus root 7. Because that's the rule, right? To get that back, we just put a plus and minus with the square roots of these two terms on either side, making sure there's a plus and minus in the brackets. It doesn't matter which order you do that. Okay, because we said a was x minus 5 and x minus 5 here, why don't I'm going to put our x minus 5 back in. So that means because I was letting a be x minus 5, really this is saying x minus 5 plus root 7. Now again, this is just this bit. I've just subbed it back in. This is going to be x minus 5 minus root 7. You can see here how the difference of two squares is working. It was x minus 5 squared, so x minus 5, minus root 7 squared. Remember that bit is just root, I should write that a bit clearer for you. 7 is just the same as, side note, 7 equals root 7 squared. So really I do have two squares which are being minused. Okay, so here you go. That's fully factorized now. Now I've got two brackets with x in each of them. That makes it very easy to go from there and actually solve an equation. Okay, and let's just quickly look at a situation where we had to solve this equation. I didn't make it equal 0, but if I did, hopefully you can see what we would do next, which I'll just show you over here. If it required you to solve the equation, right? So there was, let's imagine for a second that there was an equal 0 here. Well, then that means I would now have something looking like this. I would have my factorized form here, because we completed the square, x minus 5 plus root 7, x minus 5 minus root 7 equals 0. And how do we find what our x solutions are? How do we find what values of x will make this whole side equal 0 so the equation balances out? Remember, we're trying to find numbers that I can put in for x that will make the whole side equal 0 so the equation works. We need to make this left side the same as the right side, which is 0. And because we've got two big brackets here, and this is the whole reason why you factorize in the first place, I can just say, if this bracket equaled 0, if that bracket equaled 0, it wouldn't matter what was in that bracket because it would be that bracket times 0. It would be 0 times whatever was in there, which is always going to equal 0. Anything times 0 is 0. And the same thing goes here. I want to make that bracket equal 0. So I'm going to write out, well, I want to make x minus 5 plus root 7 equals 0. I'm going to take 5 over and I'm going to take 7 over, which means I would have to plus 5 and I would have to minus root 7. Hopefully you remember that from equations. X equals 5 minus root 7 is an answer, because if I put that in there, I will get the whole thing equaling 0, which means the whole side will equal 0. And the same goes over here. I will make x minus 5 minus root 7 equals 0, and that will give me x equals, take that over, plus 5 plus root 7. I'm going to get 5 plus root 7. So there are your two answers if that was a solve question. If it was just a factorized question, you would be done there. All right, thanks very much, guys. See you next time.